Hello, everyone, and thank you so much for joining us today. We're really excited to have you here. Welcome to our webinar, Doing More with Less, Solving Maintenance Challenges with Acoustic Imaging. My name is Brittany, and I'll be your host today. We know everybody is really busy, so we appreciate you taking time to tune in. Just a couple quick things before we get started. We are using contrast.io for today's session. If you have any questions at all during the presentation, go ahead and pop them in that Q&A panel. You don't have to wait until the end. We will save some time at the end to answer as many of those questions as we can live, but if we don't, we'll get to your questions after the fact. Yes, we are recording this, so if you want to rewatch it or share it with your team, we've got you covered. And now let's talk about who you'll be hearing from today. Joining us is Kyle Bitter, our Regional Manager for Technical Sales and Support here at UE Systems, covering the Upper Midwest. Kyle's been with us since 2022, and in that time, he's been busy helping companies across the region get the most out of their ultrasound programs. He's the go-to guy for demos, training, and support, and he's constantly out in the field working directly with our users and staying top of the latest in reliability and acoustic imaging. So welcome, Kyle.
Thank you, Brittany. I appreciate those kind words. Yeah. And welcome, everyone. Again, we do appreciate you taking time out of your day to join this webinar as we discuss all things ultrasound today, specifically the use of acoustic imaging cameras and doing more with less, and actually helping us use acoustic imaging to solve some of the maintenance issues that we face as reliability and maintenance teams. So today I'm going to be taking you through the presentation. A couple of the items that we will be discussing are what are some of those challenges that we're facing. I don't believe there is not one company, one facility out there that is 100% bulletproof or completely immune to these challenges. So how do we tackle these challenges head on and better curtail our maintenance programs to address these challenges? We'll also talk a little bit about ultrasound. What is ultrasound and how do we implement that into our facility? What are the proper uses of ultrasound and how does that technology maybe pair up with additional technologies at your facility if you are new to ultrasound, if you're looking to get into ultrasound? And then again, within the umbrella of ultrasound, we do have acoustic imaging. What exactly is acoustic imaging? What does that all curtail? What type of instruments do we utilize for acoustic imaging? We'll certainly go over that and discuss that and kind of how maybe some of those pieces of equipment can fit into your program and make it a more thorough predictive maintenance program. So with acoustic imaging, a couple of the main applications we will be discussing here today. The first is going to be leak detection for both compressed air and gas, also quantification of those leak detection efforts. Also mechanical inspections. We do have the ability to utilize acoustic imaging for mechanical inspections, pointing out bad bearings, trouble spots within conveyor belts, things like that. You do have the ability to kind of point out those bad apples and then take further action. Maybe potentially pair an acoustic imaging camera up with a Ultra Probe 15,000, one of our handheld Ultra Probes, to do further inspections, right? Capture sound files, precision lubrications, maybe with the Ultra Probe or the 401 grease caddy, things like that. So we will certainly touch base on that. Also electrical inspections and the safety use for electrical inspections. Acoustic imaging can pick up partial discharge. Anytime electrical anomalies take place inside of those electrical assets, we can actually capture those anomalies, assess them, and then recommend course of action once we've had full assessment of those issues. We'll also talk a little bit about what tool to use when, right? We're big on support here at UE Systems. We want to make sure you have the proper tool for the proper application that you guys are looking for, whether it's strictly just leak detection, or do I want to check electrical assets? Do I want to find faults within mechanical assets? You have that ability. We have a wide range of ultrasound acoustic imaging tools. It's just going to be what best fits your facility, what best fits your application, and we can certainly talk about that. You certainly all will have my information upon conclusion of this webinar, so if anyone needed any further detailed conversations about the applications at your facility, certainly happy to connect. And then last, but certainly not least, is that return on investment, right? Maybe you're looking to invest into ultrasound technology, invest into some new ultrasound equipment. How do I go about getting back that return on investment? How easy is it to see that return on investment? And just to be straightforward, very often especially with leak detection and acoustic imaging, that return on investment can be seen as instant savings. So we actually have a couple examples of that, and we will go over that return on investment as well. Now, before we kind of jump into everything as it pertains to acoustic imaging, we do have a little poll question for you guys. So we are asking, are you currently utilizing ultrasound equipment at your facility? This could be anywhere from an old UltraProbe 100, 201 analog grease caddy, all the way up to our universal UltraProbe 15,000 instrument. So we'll give everyone a minute here to go ahead and please fill out that survey. All right, excellent. So it looks like we got about 80, maybe up to 85% of attendees here that are familiar with ultrasound equipment and you are currently utilizing it. So then we have, maybe about 20% here on the call that you're unfamiliar with the technology, unfamiliar with the instruments themselves. So hopefully upon conclusion of this webinar, it gives you guys a little bit more understanding into the abilities of ultrasound, the abilities of acoustic imaging, and hopefully you can apply that to your maintenance and reliability programs. So I mentioned a little bit earlier, we're going to discuss, what are some of the challenges facing the job site these days. Like I said earlier, I don't feel like any one company specifically is 100% immune to these challenges. We all have to face these head on, and how can we go ahead and utilize ultrasound and on this webinar specifically acoustic imaging to better combat some of these, whether it be the rising costs of energy, whether here domestically, internationally, it always seems like energy costs are constantly being elevated. So how can we directly affect that within our operations to reduce those energy costs and allocate those resources elsewhere? Certainly we'll go over a few cost-saving measures. The use of ultrasound and acoustic imaging is going to be a great start for reducing those energy costs. Labor shortages, right? This is a very common theme that I see when I'm out in the field. Hey, Kyle, we love the equipment. We love ultrasound technology. I simply just don't have the resources. I don't have the time. I don't have the guys. I don't want to add more burden to their already full schedule. So how can we go about utilizing, right, doing more with less, utilizing acoustic imaging to combat those labor shortages and make sure that that job gets done, right? Whether you guys have a full staff, a partial staff, a skeleton crew, the work never stops. We still have to figure out a way to get the job done, again, doing more with less. Also talk a little bit about the gaps in skills, right? Maybe at your facility, you have an extremely talented, extremely skilled, well-trained technician who knows every technology that there is under the sun, or maybe we just hired an intern who's kind of a little wet behind the ears, doesn't really know much about ultrasound technology or has much training with ultrasound technology. How can we bridge that skill gap, again, to make sure that the work gets done? Ultrasound and acoustic imaging is going to be a great start to help bridge that gap, potentially if that's something that is happening at your facility. And then the demand for quick return on investment, but also safe operations, right? We always want to make sure, whether we're trying to identify leaks, checking electrical equipment especially, or any mechanical assets, we want to make sure these inspections are done safely. But you also want to see that return on investment that we mentioned, right? You're putting down X amount of dollars towards a new piece of equipment. You want to see that return on that equipment as quickly as possible. And like I mentioned a little bit earlier, acoustic imaging, especially with the leak detection, will be a great first step, but the use of ultrasound certainly will play in a role, getting that ROI back, but maybe more importantly, those safe operations, those safe inspections for everyone. So here's just a little chart, some stats and data to kind of back up that labor shortage that we're talking about, making sure we have the proper personnel in the proper positions, but also just making sure that we have enough staff on hand. So through a bunch of research, we found that between 2018 and 2028, there's about 4.6 million manufacturing jobs that are going to be needed to fill. However, only about 2.2 million of that 4.6 is going to be filled, which leaves us just under 2.5 million jobs out there due to skill shortage, labor shortages within the U.S. manufacturing industry. But like I said, right, the work does not stop. We have to figure out a way, how do we get the job done? How do we do more with less? A great way to start is by implementing ultrasound technology at your facility. So based on that poll question, it looked like we had maybe 15% of the attendees here today who are unfamiliar with ultrasound, right? So with ultrasound, the two main things we are always trying to detect: turbulence and friction. Friction being anything in your mechanical assets. Turbulent flow, compressed air and gas leak. Electrical anomalies produce turbulent flow as well. We are able to utilize equipment, capture that ultrasonic frequency that is produced by those turbulence and friction, which comes as a decibel reading. Taking that decibel reading and then utilizing that information to quantify your leaks, to trend the health of your assets. Basically, we are trying to identify noises you simply just cannot hear within your facility, whether it be a pressurized leak or a bad bearing, or maybe some corona that's building up in an electrical asset. Taking equipment to detect that danger sooner help curtail your maintenance and your lubrication intervals a little bit better, but more importantly, make sure we're avoiding those catastrophic failures and the unplanned downtime. Just another tool in the tool belt. We certainly would always recommend incorporating other technologies within your predictive maintenance program. However, ultrasound can be a great first step. So now you might be thinking, all right, Kyle, it sounds great. I like the thought of ultrasound. I like the thought of incorporating new equipment, but change is difficult, right? I have to get everyone on board. We need the proper training, the proper equipment. I would just ask you to take a second look at it, specifically when it comes to the use of acoustic imaging cameras, right? So those cameras themselves are extremely easy to use. That's not to say that our other equipment is not easy to use. We certainly have staff available to train you guys on that. But for the lack of a better term, we always kind of joke about it, that the acoustic imaging cameras are kind of dummy proof. Anyone should be able to just pick up the camera, aim, point, shoot, collect your data, and then generate that report. Easy to learn, easy to implement and use. Again, so if we do have a gap within the skill set of your technicians, I can have a technician maybe who isn't properly trained, properly skilled in certain areas. They can take the camera out, they can run surveys. That way, your more trained staff can apply their knowledge and their expertise to different areas, help solve different problems within your facility. Again, very easy to learn, very easy to use. It is the most user-friendly instrument that we have. Very cost-effective as well, right? Seeing that instant return on investment, cutting down on wasted energy. Every facility has energy loss through compressed air and gas. Doesn't matter if it was a factory that was built 9 months ago or a foundry 65 years ago. In my experience, every place has energy loss. Help us with ultrasound find that energy loss, find that waste to get that return on investment back within your equipment. And also the use of ultrasound specifically with the camera, it's very versatile. So we do have a bunch of instruments, like I mentioned, the camera themselves. The SI2 Pro model, we can do mechanical inspections, leak detection, and partial discharge detection. It just gives you a more universal tool at your disposal. So you don't feel like you need to just have one tool for each individual application. We do have a tool that kind of covers everything within your predictive maintenance and reliability realm. Now, that's not to say if you only wanted an instrument just specifically for leak detection, you don't really have any need at your facility for partial discharge detection or any mechanical inspections at this point. We do have that available as well. And we can certainly kind of go over that with you in more detail at a later time to figure out what would be the best instrument for you guys as well. Now, we do have another poll question here. I'm just curious if anyone has utilized if you're familiar with acoustic imaging, or maybe not at all, never heard about it. All right, so it looks like so far majority, or basically everyone, has said they heard of acoustic imaging, but they are not currently a user. Oh, it looks like we have maybe one or two personnel that are users. That's great. So again, like I mentioned earlier, hopefully after today's webinar, it gives you guys a little bit more baseline information on the abilities of acoustic imaging, kind of the applications you can foresee at your facility. And then from there, we can take it to the next step as far as scheduling any on-site visits, getting your guys' hands on some actual equipment to figure out, is this going to be a useful tool for you guys at your facility? So acoustic imaging, right? For those of you who are familiar with ultrasound, acoustic imaging has really been a game changer for us at UE Systems the last couple of years since it's been rolled out, and I've seen it in real life, right? For the past couple decades, we're walking around with our ultra probes and our headsets on. We are trying to identify turbulent flow within your inspection areas, go precisely pinpoint where those leaks are capturing, get your decibel, your intensity reading, take those intensity readings back to any reporting software for any quantification purposes. The camera takes all of that heavy legwork out of the equation for you. You are now identifying, as you can see on the screen, where those leaks are coming from. So you can quickly and precisely pinpoint where those leaks are coming from, but also helps you eliminate any false positives, right? So if I'm scanning an area and I see something that's reflecting off a solid surface, like a wall or a hard cabinet, you know the wall's not leaking. There definitely is a leak in that area. It's just up to us to kind of properly, as inspectors, it's up to us to properly pinpoint where those leaks are coming from. The camera itself will actually give you a real-time CFM. You can change that metric to liters per minute as well. It'll give you your decibel reading, also an annual cost avoidance. So if I have all of my metrics accurately put into the camera, as far as your kilowatt per hour, electricity costs, operational times, things like that, you will get a real-time annual cost avoidance dollar amount back in real time, even before I generate that, as I'm looking on the camera screen in real time, right? So we are taking all of the time-consuming legwork out of old traditional leak surveys and mechanical inspections, electrical inspections, and letting the camera do all the heavy lifting, all the legwork for you. It'll even tell you if it's identified an actual leak, or maybe it's just turbulent flow in that general inspection area, discharge from a piece of equipment, sonic reflection, things like that. Again, makes it extremely user-friendly, combining sound data and visual imagery, so you have fast in-the-field diagnostics, and you can go ahead and make your repairs at that point, save your images, save your videos, generate a report, print off that report, send it off to the proper personnel who needs to go ahead and make those repairs, make those replacements. So we are now seeing ultrasound on a screen versus simply just hearing it for the past how many decades. Again, for us at UE Systems, it's really been an extreme upgrade, a big game changer in the realm of ultrasound. So the first application here is leak detection, right? For those of you who are ultrasound users, you might agree with me on this, that leak detection is kind of the most basic application. It's probably the easiest to learn, the easiest to get experts at. Again, I talked about those traditional methods, which can be a little bit time consuming, a little bit more labor intensive. We are sending a staff member out with his wand and his headset. He is walking the entire facility trying to pinpoint where leaks are coming from. This can be a time consuming, although it is tried and true method, it can be a time consuming method. So again, with the use of acoustic imaging cameras, we have the ability to scan large areas quickly and also safely. So the SI2 Pro camera, for example, has a detection straight line distance of 656 feet. Now, again, we don't necessarily teach standing 600 feet away from a leak when you're trying to quantify it. We want to always get as close as possible, but just know you do have great detection distance, that you can always make sure you're at a safe distance. So we have operating equipment, especially when it comes to the realm of electrical inspections. We want to make sure safety is first and foremost with that. The cameras also have the ability to capture multiple leaks at once. So if I feel like I have multiple leaks in a small area, it will actually precisely pinpoint on the screen what leak it's picking up and show you other competing leaks within that area. So there are a few settings you can adjust on the camera, again, to help you quickly scan those areas. And actually what we're seeing here on the screen right now is just a snapshot from our cloud-based dashboard. We do have a cloud-based platform that comes with the camera. You are able to utilize this for your quantification purposes. I go out there, I collect all my images or my videos, whether it's leak detection or electrical scans, report that back to the software. And this is actually meant to be a working document. So I can put this on a shared network. I can have multiple staff look at this. You can check off what leaks have actually been identified on your survey. And then more importantly, get an accurate cost avoidance, right? Update your operational times, your cost metrics to make sure we get an accurate annual cost avoidance. So here's a quick case study that was done by a paper manufacturing company. So during a 20-minute quick inspection, right, just 20 minutes, With the SI2 LD model camera, LD for leak detection, they were able to find a total of 12 just compressed air leaks, well worth over $4,000 in production department alone. Now that $4,000 mark represents about 21% rough cost of the actual camera itself. And again, that is just during a 20-minute survey. For those of you who have utilized ultrasound for leak detection surveys in the past, I can guarantee you're probably out in your inspection areas for much more than 20 minutes. So imagine if they spent 40 minutes, 60 minutes, 120 minutes out there. Imagine what that number potentially could be. And again, this is just on compressed air. Once we start to get up into any specialty gases, then that dollar amount really astronomically inflates. So again, we're finding these leaks quickly, but we're also able to quantify them in a very accurate process. And the cameras themselves work very well inside of really any type of environment, whether I'm, from personal experience, whether I'm standing next to a turbine or I'm in a still laboratory trying to identify any leaks. Because of the MEM sensors on the front side of that camera, we are going to be eliminating all ambient noise in your inspection area and just focusing in on where that leak is coming from, right? Being able to identify it, eliminate ambient noises. Again, whether you're next in a compressor room next to a turbine or you have a complete silent still laboratory, we are going to be able to precisely and accurately identify where those leaks are coming from. Second case study when it pertains to leak detection was done at a brewery. So they found a 1.8 CFM CO2 leak. 1.8 CFM, that's a pretty hefty leak, as you can see, was just over $13,000 a year. If they were to identify 2 of these CO2 leaks, that return on investment would be instant. It would pay for the entire camera just in those 2 leaks alone. So I can imagine many of you are trying to think, if you do have any gases at your facility, how often are those gases leaking? How often are you identifying where those leaks are coming from? And as you kind of add up the number of leaks and the potential cost of that leaks, right, that return on investment really can be seen basically instantly at that point. So I talked about the ability with mechanical fault detection of the SI2 Pro camera. So we do have, like I mentioned, we do have cameras beneath the Pro model that are just either for leak detection and or partial discharge detection, but the Pro model will spot out those bad actors. If you got a noisy bearing, something ain't going right, as you can see in the picture here on this conveyor, the camera is picking up that friction that's being generated by these noisy or these bad bearings. From then, we can also pair that with maybe an Ultra Probe 15,000 or a 401 grease caddy if these are grease bearings, to do further diagnostics at that point. Take sound files, utilize our spectralizer software with the 15,000 to analyze those sound files to figure out where that issue is taking place inside of those bearings. Now, with acoustic imaging, it is very directional, and ultrasound will not penetrate solid objects. It may be a little more difficult to diagnose any potential enclosed bearings. With the acoustic imaging camera, that's not to say you can't. We would just always recommend pairing an Ultra Probe with the camera for those mechanical inspections. But really, if we're able, again, on this conveyor, as you can see, able to have an exposed bearing, identify those issues, it allows us to be proactive and not reactive. Plan out your maintenance, plan out your lubrication schedules if needed, but avoid those unplanned downtime. That really is going to be the main aspect of the mechanical fault application with the SI2 Pro camera. And then the third application is electrical discharge or partial discharge detection. So this, I feel personally, this is the most amazing part about acoustic imaging cameras, is that it is going to give you real-time information. You spit back a report, and it's going to tell you precisely what the camera heard based on the AI onboard software severity assessments, and then gives you the recommended course of action, right? You have that great detection distance up to 656 feet away with the SI2 Pro model, so we can safely scan those areas. And if you can actually see on that image, on that camera image in the upper right-hand corner next to the normal filter, there is a PD diagram that pops up. This will give you real-time feedback if I'm scanning an area and there actually is some type of discharge that's taking place. That graph will start to populate. From there, I can go ahead, take an image, capture a video. More often than not, a video sometimes suffices for electrical equipment, and then play that back through the software. What did the camera hear? What is our next recommended course of action? There also is a 2 and an 8 times zoom. So if we are standing a couple hundred feet away, we have the ability to zoom on a little bit closer and precisely pinpoint where those electrical anomalies are taking place. So I mentioned the reporting aspect. This is actually just a snapshot of a PDF that gets generated through the cloud website. Once you've captured all those images or videos with your camera, specifically for partial discharge, right? So for this example, it is classified as surface or internal discharge, but it appears to be strong and might escalate rapidly to complete insulation breakdown. So our recommended course of action is take immediate action to avoid any further or any more severe consequences. Again, we have the image, you've got your PRPD pattern there in the lower right-hand corner. This, again, can be a very useful tool for someone who is not necessarily an electrician, or they're not very familiar with your electrical assets. I can have that staff member go out, detect these faults at a safe distance, generate that report, pass that report on to a more skilled, properly trained technician who can further address it, make sure they go through the proper procedures for your repairs and your replacements at that point. Another example, right? This one was classified as surface internal discharge. However, it appears to be weak. Our recommended course of action was periodic inspections. So maybe they are scanning these electrical assets every month, every 5th week. After running this report, maybe they want to up that to every week or every other week, just to make sure we have proper worker safety, but also early detection of that issues. Avoid any potential issues escalating into severe catastrophic issues. And I feel that is the most beneficial aspect of the camera, is that it takes all the hard work like out for you guys. With a 15,000 or a 10,000 Ultra Probe, we capture sound files and electrical assets. We take those sound files back to Spectrum Analyzer software to diagnose. Again, the camera does all that for you guys right away. So I can go out, scan electrical equipment, generate a report, compile that report, and kind of address the severity of it within 10, 15, half an hour type of deal. A lot less time consuming, but takes kind of the legwork and all the hard aspects out for it. So allows multiple users of the camera to go ahead and capture these images in these videos. So we talked a little bit about having the proper tool for the proper application. I mentioned a little bit earlier that acoustic imaging cameras are very directional and they do need straight line of sight. Ultrasound, for those of you that are familiar, does not penetrate through solid objects. So as you can see in the picture there, the upper left-hand corner, they are using our Ultra Probe 15,000 to scan the seams of that electrical asset, maybe a vent if it's available as well, to listen inside to hear what's going on. Often I do see out there now, little IR windows are now being developed with ultrasound in mind as well, where you can actually stick your Ultra Probe into those electrical assets to hear what's going on. If everything is safe, I can then safely open up that cabinet, go ahead, use my camera, and then do further diagnostics at that point. But utilizing the camera on enclosures is not going to be the best ultrasonic procedure, in that we would want to use an Ultra Probe to safely open up the cabinet. And then from there, you can certainly utilize the camera, scan your areas, generate reports. You can also take it a step further, right? Bringing our partners in from FLIR, for any infrared cameras for resistance issues. Ultrasound and infrared are technologies that work very well together, and we would highly recommend you pair the technologies up for a more thorough predictive maintenance program, especially when it comes to the scanning of any electrical assets. So that return on investment, right? Maybe that is going to be the single biggest factor you guys are looking into when it comes to investing into a new piece of equipment, investing into ultrasound technology in general. So maybe if tool A was an Ultra Probe 3000, one of our older instruments, you go out, you find one leak, that leak is $1,000, you repair it, you save $1,000. In that same time frame it took me to find the one leak, maybe I'm using an acoustic imaging camera and I find 10 leaks. Repair that, save it. Again, that is a $9,000 net benefit. We are finding more leaks in the same time, or often more in less time than you would with traditional ultrasound methods. being able to identify, quantify, and repair those leaks in a timely fashion with acoustic imaging is kind of the end game, the name of the game that we're looking for. And again, with the cameras themselves, the tool sensitivity and then the distance features, those will auto-correct themselves up to a certain point, right? So with my SI2 Pro camera, if I'm standing 10 feet away from a leak, it's going to auto-sensitize that camera. It's going to actively detect that distance to the leak itself. So when you generate that report, it will tell you that. And it'll give you more detailed information back. So those of you who have maybe used an ultra probe in the past, right, we got to make sure we have the instrument tuned to the proper channel, 40 kilohertz frequency for any airborne inspections. And then you got to adjust your sensitivity based on what I'm hearing. If that leak is a little bit too soft, I'll increase my sensitivity. If the sound is too loud, we'll decrease that sensitivity. Again, the camera takes all that legwork out for you guys. It will auto-sensitize, and it will auto-detect the distance between you and that leak as well, and then generate that through the report moving forward. And then really the simplicity of the tool, I think, along with the reporting aspect, is the best benefit of acoustic imaging. Being able to send any staff member out there to quickly identify leaks, scan electrical equipment, see if your noisy bearing on your conveyor belt is in a faulty state. This allows multiple users of the instrument where you don't necessarily have to be completely ultrasound trained, level 1 and level 2, to utilize the equipment. And then data integration, whether it's mechanical and PD monitoring over time. We do have a data management software, our DMS software, that we pair with our ultra probes and our grease caddies to trend the data of mechanical assets over time. You also have the ability inside of the software to keep a history of all the reports that you run with the camera. So if I'm just using it for all leak detection, or if I'm only using it for partial discharge, you have the ability to store all those reports and kind of curtail and see, all right, how often are things failing on us? How often are leaks actually being presented to us on certain assets throughout your facility? Early detection ROI, right? The earlier we can detect things, the faults that are associated out there, the lower cost in repair. We can properly plan out maintenance and repairs. We need to lubricate mechanical assets. You guys can properly go about that. We are not having to live in that reactive state, right? We are being proactive about our maintenance, and we are decreasing that unplanned downtime. Again, this kind of just talks a little bit more about the tool sensitivity, the improved detection via the AI. So you have confidence that the data you're collecting is going to be accurate. You eliminate those false positives. Know that the CFM I'm collecting is going to be accurate. Know that the decibel reading I'm getting from a mechanical asset is going to be accurate. And then from there, we can help you quantify, help you condition-based monitor, and actually start trending that data you're looking to get into. Inspection speed, right? Finding those leaks, finding those faults, those anomalies quickly and safely. So if we're able to provide 50 to 90% reduction in time spent inspecting versus point scanning, imagine where you can spend that time and resources elsewhere. So if in a 40-hour year, we're spending, 40 hours a year, we're spending on ultrasonic surveys with traditional methods. If we're cutting that time in half, you can apply that time saved to repairs, to other areas of your facilities, other jobs that need to get done, right? Because if you are in a labor shortage, if you have a gap within your skilled workers, the work doesn't stop. We got to figure out a way, how do we go ahead and repair? How do we do our proper maintenance? Inspection speed, being able to identify quickly and safely will be certainly a good head start on that. And then the last thing here, before we do have a final poll question, and then we'll open up to a little Q&A session as well, is the HR optimization, right? I talked a little bit earlier about the need to have experienced technicians, and maybe that number of experienced technicians at your facility is a very low number, right? So we want to make sure that the jobs and the duties that they're assigned to are, are prevalent, and it makes most sense. So potentially having an inexperienced technician take a camera out, run surveys, check electrical assets, see if you got any faulty bearings within your conveyor belts. They can then take that report back to more experienced technicians, again, for the higher return on investment activities. Apply those assets and those resources where they need, not that you're spending all day, every day out there trying to identify leaks or trying to identify partial discharge. Make sure that we have the proper staff tuned into the proper applications and the proper jobs that they're supposed to be doing. And then again, the data integration, allowing for those inexperienced technicians simply just collect that data and then pass it on to the more precise decision makers. All right, so I think we have one more final poll here, and then we'll actually open it up, do a quick little wrap up, and then we'll open it up to some question and answers. So today, as far as acoustic imaging goes in the world of ultrasound, how helpful was this for you? Good refresher? Is it a good starting point for you guys? Are we looking to gather more information, or did Kyle just kind of drop the ball on everything here? Well, it's great to see that some of you are interested in learning more, and that's definitely something we can help you support moving forward as far as, any on-site visits, connecting on a call to kind of go over your ultrasound goals, figure out what's going to be best for you when it comes to ultrasound and specifically acoustic imaging cameras. All right, excellent. Very good. So again, just to wrap things up here a little bit, right? The use of acoustic imaging cameras, we are looking to cut labor time while boosting cost-saving efforts. Fast inspections lead to more assets and resources being able to apply to other areas of your facility. You can be confident in the data that you're collecting is going to be accurate and precise, but also see that return on investment really to help better your ultrasound and better your predictive maintenance program.
Awesome. Well, thank you, Kyle. That was fantastic. And again, if you guys have any questions, feel free. Now's a great time to just throw those into the chat and we'll be able to go through. We definitely have some questions for you. The first one is, does the camera need to be calibrated?
Great question. It does not. So every individual MEM sensor on the camera itself is calibrated at production. Now, FLIR does provide an ultrasonic tester that you can kind of check the calibration. It doesn't really necessarily calibrate your gun or your camera, excuse me. Very similar to kind of what our wearable tone generator does with the ultra probes themselves. But long story short, you do not need to do an annual calibration with the camera.
Great. And when would you choose to use acoustic imaging versus the traditional methods or procedures?
So again, acoustic imaging is going to serve very well for all of your airborne inspections, leak detection, partial discharge detection. Also, it can spot out those bad mechanical assets. However, if I'm looking to establish a precision lubrication program, or maybe I have steam traps and valves I want to test, the camera itself probably wouldn't be the best tool served for that application. We want to definitely make contact with those applications, whether it's a steam trap, a bearing, a valve, to hear what's going on inside. Again, ultrasound won't penetrate solid objects. So I need to have some form of contact on that asset to actually hear what's going inside. So think SI2, SI1 acoustic imaging cameras, more for your airborne, even though the Pro does have the mechanical inspection, they'll probably be better served for all of your airborne ultrasound.
Great. And then if somebody were looking to start their journey, we do have a lot of different cameras. What's the easiest way for them to choose what's right for them in their facility?
Right. Excellent. Great question. So like I said earlier, we do have a wide range of cameras, all the way from the SI1 LD to the SI2 Pro model, and it varies quite drastically in price. So it really comes down to your ultrasound goals. I would recommend you reach out to UE Systems, myself, maybe you know a current local contact within your area, and we can certainly help figure out what might be the best instrument at your facility. Again, if you're only looking for a compressed air leak detection, the SI2 Pro model probably won't be the best camera for you. It might be the SI2 LD or the SI1 LD based on budget, restraints, other metrics like that. So I would certainly recommend reach out to UE Systems, reach out to your local representative, and we'll kind of help you build that roadmap to success.
Perfect. Okay, I think that's all we have time for today. Kyle, thank you so much for spending the time with us and educating us a little bit more. And thank you to everyone who joined the presentation. We know that you could have done a lot of different things on your lunch hour, but you chose to enjoy it with us. So there will be a recording of this that will be sent out to all. And we look forward to you on one of our next lives.
Thank you, everyone. Have a nice day.